FastMCP 3 introduces a transform-based architecture for modifying tool schemas through a pipeline pattern, where components flow from providers through configurable transformations before reaching clients. This deferred transformation mechanism enables runtime modification of tool metadata and argument schemas without altering the original source implementation. The upcoming code demonstrates how to initialize a FastMCP server instance, register a tool with its original schema, and then apply a ToolTransform to modify the tool's name and description as it flows through the transform chain. This approach maintains separation between the internal implementation details and the client-facing interface, allowing for cleaner abstraction boundaries. From FastMCP, import FastMCP. From FastMCP server transforms, import ToolTransform. From FastMCP tools ToolTransform, import tool, transform config. MCP equals FastMCP server. At MCP, tool. Def verbose internal data fetcher query. SDR. Fetches data from the internal database. Return F results for query. Hash rename the tool to something simpler. MCP, add transform tool transform. Verbose internal data fetcher. Tool transform config. Name equals search. Description equals search the database. Hash client C search with the cleaner description. This code demonstrates FastMCP's tool transformation capability, specifically using ToolTransform to modify how tools appear to clients without changing their implementation. The pattern shows a deferred transformation approach where the original tool, verbose internal data fetcher, is registered with its technical name and description, then transformed to present a cleaner interface as search to clients. The transformation works through FastMCP's pipeline architecture, where components flow from providers through transforms to clients. Here, ToolTransform acts as a middleware that intercepts the tool's metadata during the listing process, mapping the original name to the configured ToolTransform config. This is particularly useful when you don't control the original tool source, like with mounted servers or proxies. The key advantage shown is interface simplification. The internal implementation keeps its descriptive name and documentation for developers, while clients see a more concise version. This separation of concerns allows maintaining technical accuracy in the codebase while optimizing the API surface for usability. The transform only affects presentation, not functionality, as the original tool's behavior remains unchanged. Let's break it down. From FastMCP, import FastMCP. Imports the FastMCP class from the FastMCP module, making it available for creating MCP server instances with the specified identifier functionality. From FastMCP server transforms, import ToolTransform. Imports the ToolTransform class from the FastMCP server transforms module, which provides functionality for modifying tool components as they flow through the server's transform pipeline. From FastMCP tools ToolTransform, import tool, transform config. Imports the ToolTransform config class from the FastMCP tools ToolTransform module, which provides configuration options for transforming tool schemas in FastMCP. MCP equals FastMCP server. Creates an instance of FastMCP with the server identifier server. The string parameter serves as a label for identification in MCP protocol handshakes, allowing clients to recognize this server instance. No functional configuration or operational mode is set by this parameter. It purely acts as a human-readable identifier. At MCP, tool. Def verbose internal data fetcher query. SDR. Fetches data from the internal database. decorates the function verbose internal data fetcher with @MCP tool, registering it as an MCP tool. The function takes a string parameter query and returns a string, with the docstring fetches data from the internal database, serving as the tool's description. FastMCP will automatically use the function name as the tool name, generate an input schema from the type annotation, query, SDR, and handle parameter validation.
Return F results for query.
Returns a formatted string containing the text, results for, followed by the value of the query variable. This creates a user-friendly output message that incorporates the query term in a readable format.
MCP, add transform ToolTransform.
Adds a ToolTransform to the MCP instance's transform chain. The ToolTransform is initialized with an empty dictionary configuration, which will be used to modify tool schemas as they flow through the server's component pipeline. This transform will apply to all tools from all providers, running after any provider-level transforms.
Verbose internal data fetcher, ToolTransform config.
Creates a ToolTransform config instance named verbose internal data fetcher that will modify tool schemas as they flow through the transform chain. The configuration will apply deferred transformations to tools from providers, allowing schema modifications like renaming tools or reshaping arguments when clients request available tools.
Name equals search.
Assigns the string value, search, to a variable named name. This creates a simple string identifier that can be used elsewhere in the code, though its specific purpose isn't visible in this single line. The variable name now holds the exact string search for potential later use.
Description equals search the database.
Assigns a string value, search the database, to a variable named description. This creates a simple text descriptor that could be used elsewhere in the codebase, though the specific usage isn't visible in this segment. The value is a plain English sentence that appears to describe a database search functionality. FastMCP3's transform-based architecture enables runtime modification of tool schemas through a pipeline pattern, where components flow from providers through configurable transformations before reaching clients. This deferred transformation mechanism allows you to modify tool metadata and argument schemas without altering the original source implementation. In this example, we initialized a FastMCP server instance, registered a tool with its original schema, and then applied a ToolTransform to modify the tool's name and description as it flows through the transform chain. The original tool, verbose internal data fetcher, is registered with its technical name and description, then transformed to present a cleaner interface as search to clients. This approach maintains separation between the internal implementation details and the client-facing interface, allowing for cleaner abstraction boundaries. The key advantage demonstrated is interface simplification. The internal implementation keeps its descriptive name and documentation for developers, while clients see a more concise version. This separation of concerns allows maintaining technical accuracy in the codebase while optimizing the API surface for usability. The transform only affects presentation, not functionality, as the original tool's behavior remains unchanged.
The server exposes verbose internal data fetcher, while clients invoke search, and both paths return identical results.